Hey, welcome back to the Build It Basement. We are once again working on our Voron 2.4R2. I should just record that and have it reset every time I do one of these things. So we're on about episode 15 or so, or video 15, however you want to look at things. And I gotta tell you, I've been struggling with how to deal with the fact that LDO has its own wiring setup. The original Voron has its own wiring setup. I'm making some modifications here and trying to simplify things for people so that this is not the world's most confusing thing. Because I will tell you that I'm getting a little bit lost in the shuffle in terms of what manual, what documentation we're using at this point. So we're going to jump in this, and we still have a couple videos to go on this, and we'll see how this goes. But by all means, if you have questions, if you have concerns, if you have anything in there that you want to actually just leave me a comment and we can discuss it. I have email addresses I can throw at you, whatever you want to do. So let's get into it. Okay, so this is where we left off last time. Printer's now on its literally on its backside, and we have excuse me, we have our 24 volt meanwhile, we have our 5 volt meanwhile, we have our SSR, we have our Wago setup, or Wago, depends who you talk to, power inlet, and basically our Raspberry Pi, our Octopus, and our breakout board for our LDO kit. So this is where the problem becomes. LDO does not give you a 5 volt power supply. They don't use the Wagos, which this is minor because this is actually more cosmetic than anything else. There are some, mechanical reasons to go with the Wagos versus what they give you. But in terms of actually wiring things together, it's more mechanical than anything else. But the rest of it is the fact that the wiring harnesses that LDO gives you are either too short or too long. Even if you follow their documentation, I don't think these wiring harnesses are properly sized to build a printer. One of the main goals that I had as I'm doing this wiring, is to keep all of my AC wiring over here in this corner, which is where the AC comes in. I think it's safer that way. You'll see a lot of times when you deal with PCB boards that have AC and DC current on them, the AC is actually mapped out on the board. It's actually squared off with markings because AC voltage tends to be, for the most part, more dangerous than DC voltage, depending on obviously the amount of voltage you're dealing with in current. So all that being said, we're gonna go through this, we're gonna get through it, we're gonna work through it. We're gonna see if we can get some steppers hooked up today, and then we're gonna look at a couple other things. Before we get too far into it, something really silly and stupid, but I'm gonna go ahead and get the heatsink on that Raspberry Pi because honestly, I just wanna get rid of this little package before I lose it. Hope you guys are liking the new camera setup. Again, constantly trying to make things a little bit better. If you don't like this, or if you have other suggestions or comments, by all means, feel free. So I'm gonna go ahead and slap that right on there just like that. And that came with the LDO kit, even though they're not giving me a Raspberry Pi with the kit. That Raspberry Pi actually came from, what's that company called? Canakit. So I had a bunch of those left over. So on top of that Raspberry Pi, there's also a PCB board, that goes there, that gives us our 5 volt input. It also gives us our ADXL connection, and there's another connection on there too. Not 100% sure on that. There's very little documentation about some of this stuff from LDO, and you do have to look around to multiple documents to find it, which is part of the issue that I'm having and part of the concern that I expressed here in the beginning of the video. Placement of this, for one, they show it on a Raspberry Pi Zero. They show a different board on a Raspberry Pi, maybe a 4 or 3B. Actually, we can look at that real quick. Hold on, let's go to this, and let's find the screen for it. So on these screens, they don't even show it because they're powering it via USB. It's not on that one. It's not gonna be there. 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 Input shaper. Okay, so this is the board that we have. Okay, so let's see here. Oh, this is a serial interface. So basically, I receive, transmit, and ground. So we won't be using that as far as I know. But yeah, like here. So that's showing a completely different PCB than what we have in our kit. It's the same function, connected to a different, or in a different method. So that is that PCB connected to a Raspberry Pi. It looks like a 3B, might be a 4. I don't know. Here is another version of it, but still doesn't quite match ours because this doesn't have the serial interface on it. If you remember, ours has, up here in this little corner. See, ours has another little interface there. So that one doesn't have that. And then finally you have one that shows that, but it's on a Pi Zero. And especially for a first-time builder or somebody who hasn't built one of these before, you may not realize that the pins or the header pins on your Raspberry Pi, these little guys right here, are pretty much the same across the Raspberry Pi brand. So the documentation kind of, lackluster, I guess, is the best thing I can say. So shoot right back over to this. So this guy is going to go here. And the reason why I know that is, for one, documentation kind of leads you to believe it. But two, there's a colored red and a silver screw on here. And I know that there's 5 volts down here. I know there's ground on the third. And I checked continuity between those, and that's what we have. The other pins are used for the AXDL, ADXL. Man, I get those letters messed up. Leave me a comment if I messed them up again. Get rid of that little bag. And we have that serial interface right there. And then obviously we have our outputs here for cameras or screens that we can use on a Raspberry Pi, as well as a couple of mini HDMIs. So that's on there. Another board that they have and they provide you, if you are going to get 5 volts off of your, and this actually came with the LDO kit again. This actually clips in right here on the board if you're not using a 5-volt power supply, okay, and you want to use 5 volts off of this. This actually pulls 5 volts off of the board. You may have to configure your jumper from 12 volt, 24 volt, 5 volt separately, depending on what you're doing specifically. I believe that will change the fans. It may change that. I didn't do any research on it, to be honest with you, because I'm not using this. But these right here, and again, back over to this screen, just so I can get rid of some tabs here about some things I wanted to talk about. Where is it here? Octopus Board, right here. So some of these have issues. So some of these guys have issues and they want you to check them. And again, LDO is a great company, but there obviously are some issues and things you need to be concerned about. And I guess in the manufacturing, some of these are actually crossing the 5 volt in the ground. So there's 2 different patch pads on this. One is all ground, as you can see it dictated here, GND. And then there are 5, 6, 7, 8 connections here that are not supposed to be connected directly to these. 5 volts coming through here, ground coming through here, ground obviously showing as to what it's connected to, but these aren't supposed to connect directly. So they want you to test pretty much whether or not there's continuity between the pads on these 2 things. And if there is continuity between those pads, you have a defective board, so you can't use it. So all the more reason not to use it, right? And we're not. So yeah, be aware that there may be, and the thing is you don't know what you don't know. And I hate when people say that, but literally in this particular case, if you don't know that there's an issue with that, you're not going to know it until you cause yourself a bigger issue. So frustrating. And that plays in again as to how to approach this. Yeah. In some ways, this might be easier to self-source, All right, so we'll get on with this a little bit here. But where we left off last time was with the wiring, and we did the AC wiring. And I thought this cover came off. I was pretty sure it came off. Does it not come off? There we go. You don't really have to take that off. I just wanted to do it so you could see. If it wasn't for the video, I wouldn't take that off because there's no need to. But pretty much you have your negative, positive, negative, positive, negative, positive, and then you have output for your bed. And we're using an AC bed, so we don't need this bed output specifically for high current. So we'll get to that in a moment. But one of the things I wanted to show here is, so they basically go, again, negative, positive, negative, positive, negative, positive, positive, negative. And it's some oddities here. Why would you do that? I mean, I know I know on the circuit design they probably did it so they keep the two positives together, but now they get the ground separated, which I'm sure there's a big ground plane on the back of this, but that's gonna throw somebody off. I'm like sure of it. That's gonna throw somebody off. Nonetheless, continue on our way here. Let me grab a screwdriver and we will install the harness I built. Now the harnesses I built are using what I call zip cord. A lot of people call it zip cord. And basically it's two wire leads. These are, I believe these are 16 gauge. I went a little bit higher in the wire gauge. Going up on wire gauge in terms of thickness, which means a lower number, isn't a bad thing. However, if you go down in wire gauge, meaning, you know, basically a higher number, it's inverted. Like a 20 gauge wire is larger than a 24 gauge wire. If you go with a smaller wire, basically you're reducing the amount of current that wire can carry over a distance. There's calculations you can do. Really short wires that are relatively thin are okay because there's not a lot of resistance there. Think of it almost like a garden hose with water going through it. The bigger the garden hose, the easier the water can flow through it, the less issue you have. Meanwhile, if you have a thinner garden hose, you get less through it. In this case, instead of just having less pressure coming through the water hose, you're gonna wind up with some heat, and you don't want heat in your wires, you want heat where you wanna put it. So we're gonna hook this up to our positive and negatives. I'm gonna loosen all these guys up. And it does not matter in what order I'm doing this. These are all the same. What does matter is the original wiring harness for this. I'll show this right here. Has 3 positive leads and a single negative lead. Now, I understand, worry about comments about that. I understand that the grounds on this may be common, meaning they're all connected. My problem is, for whatever gauge of wire you have going into a circuit, you should have the same gauge of wire coming out. Nobody would wire a house with, you know, say 12 gauge copper wire on the line, and then on the neutral have, you know, 30 gauge wire or something really small. It's just a not proper. You don't do that. So again, minor cost savings, I think, but to what degree, you know? We're seriously talking about pennies now. Pennies do add up, I'll give them that, but it's, you know, it's probably not going to cause you any huge long-term ill effects or headaches or anything like that. But I think a lot of people that put these printers together, part of the pleasure of putting one of these printers together is the fact that you can do it with a certain level of precision. And precision isn't always physical. It also has to do with, you know, how you're doing something. So doing it to the best of your abilities, using the best items you have available to you is part of that. And when you forego some of that, you forego doing it properly. Okay. So the reason why this board has multiple inputs is so you can utilize multiple power supplies if you choose to. Some power supplies may be smaller. The good thing about it is, I'm going to slide this down a little bit. The good thing about it is that it gives you some flexibility. I didn't loosen up that last positive. It gives you some flexibility in terms of what you're doing. I don't think most people are going to use multiple power supplies, but there might be an odd case here or there where somebody's using 2 smaller power supplies that may not be able to provide quite as much amperage or wattage. So they got that going for them. It's not all bad, right? Okay. So neatness counts, like I've said before. I'm going to try to keep these all nice and straight. I had one of my viewers, BRADTN, upset with me the other day. Brad was upset with me because there was no Loctite in that video. So if you saw my previous video to this one and wondered why the heck I have a big ball of Loctite across the thumbnail, go back and look at it, you'll see it. But the reason for it is because Brad was upset I didn't use any Loctite in that video. So and that leads actually to another note real quick, is on electrical connections. As much as it would be great to have something on them to basically hold the wiring a little bit better, the connections, do not use Loctite on electrical connections. I'm gonna go ahead and slide this back on now. Again, you don't need to take this off to, actually you do, to get those screws, now that I think about it. I'm a pain in the butt. There we go. All right. So that's a custom wiring harness I made. Basically, it's the wiring inside of it, along with some I forget what they call this material, but basically it expands and contracts depending on if you push it in or out. It's like a loom, only it's solid. And then basically some heat shrink on the ends of it to stop it from frying and keep everything together. All right, so we have that done. Next thing I want to talk about real quick, and next part of this, is the plastic railing that is provided. That's very, I guess I'll call it very popular now. And what I want to talk about is, I'm not going to put as much on here as prescribed by LDO in their manual. And we can take a look at that for a second. Right over here. So LDO kind of says you're going to put a piece up top, piece down this way, piece across the bottom, and a piece on this side, and one down the middle. So pretty much every place and any place you could possibly put a wire, they want to put one of these rails in. And I want to keep my wiring kind of a little bit neater than that. I don't want to have wiring everywhere. So I want to keep my wiring on the printer here. I want to keep it across the top. I want to keep it across the bottom and down the middle. I don't think there's a need to have much over here. I think everything we have can go towards that center part. There's not much I can do here. I do need to bring the stepper wires in, but again, I think we could bring these in and then up here towards their connectors too. For the random wires, when I say random, for the few wires that they're going to be on this side, again, I think we can kind of neatly bring those aside as opposed to bring them to another rail right here. I don't really have room on this side to even put one of those rails because we went with a Wago system. So that's that. All right, so let's look at this real quick. I'm going to give some quick measurements of what I have I don't know what these things are called. Chintzy plastic railings for wire mounting is what I'll call them. But my longer one, which is the one going down the middle right here, it's about 11 inches or, you know, about 285 millimeters, 28 centimeters. The smaller one's about 9.5 inches, which is about 240 or so millimeters, 24 centimeters. You want to make things easy, right? As opposed to complicated, use a metric system. So we're going to use a little bit of this double-sided 3M. And the way I'm going to do that is I'm actually going to, you know what, before we do that, another quick tip. Another quick tip is we're going to quickly clean. I don't think there's much residue on these, but anything with an adhesive surface, like you know, any type of double-sided tape or even normal tape will work a lot better if you clean the surface properly before you do it. So if you ever have, or if you have had issues with adhesion on some of these products, I suggest you give that a whirl, clean things with a little bit of alcohol, get any oils off of there, is pretty much what you're doing. So get that off. And then another thing you can do too, if you're really concerned about it, is you hit it with a little bit of heat. Once you hit a heat, it really makes those glues kind of meld a little bit deeper and better into those plastic materials, or whatever material you're gluing or taping together. So I'm not gonna do that in this case. There's not really going to be much strain or stress on these parts. And in actuality, you probably don't even need to apply tape all the way across. Probably get away with just putting a couple small pieces on there. I have extra. And having extra is kind of the name of the game. If you're on a budget and you build a printer, definitely budget yourself a little bit of extra to buy spare parts. For one, you might need them while you're building the printer. You might decide to do something slightly different that requires you to have a little bit. You might mess something up which requires you to have something. You know, having a bunch of M3 screws, M5 screws, no, not that many M5 screws, but M3 screws of different sizes, washers, spacers, heat certs. Most kits come with plenty of those, but having some, building an inventory of those, especially if you're going to get into the 3D printing and building maybe 1, 2, or more printers and maintaining your printer, it's not a bad idea to buy that stuff and have it on hand rather than having to wait for it. Because the worst thing you could possibly do in terms of once you have a printer is having to wait for parts to come to you because you don't have any on hand. So the primary benefits of building a printer is the fact that you know how it goes together, so you know how to fix it. If you get rid of that primary goal or that primary benefit, you're kind of limiting yourself a little bit. Personal opinion. And you know how opinions are. And I'm sure you have your own. All right, so there we go. This is my larger of the rails, the 11.5 or so. 11.5, forget. That one's going straight down the middle. I'm gonna rendezvous with our wire going into the bed. I'm gonna try to keep this relatively straight, but two things. One is this is going to be buried in the bottom of the printer. No one's going to really see it. That matters, except for you. So you go ahead and be as picky as you want to be based on the fact that you're not going to see us very often, and probably nobody else is going to, other than the few thousand people that probably wind up watching this video in the long run. So I'm good with that. It's probably better than most would have done in the first place. Oh, I got a broken wire right there. We'll have to fix that. It happens. Probably over crimped it. So I guess we'll have to take that off and crimp it. Best tool I have is my teeth. All right, so this one I'm gonna put right up here. Again, I'm gonna try to center it as much as I can. I'm not going to worry overly about it. Of course, I put away the little set of crescent wrenches I was using. But basically, I'm just getting in there and I'm just applying some pressure. Enough pressure to move the printer around, I guess.
Alert! Alert! Person has left the house area.
I guess the dog has run away.
Alert!
So, speaking of that little automation I have, my dog has a thigh collar, which is kind of neat if you're a dog owner and you have a dog that likes to wander and you're in a place where a dog can wander a little bit. And it basically keeps dibs on the dog as to where he is at all times. It has a base with Bluetooth. It keeps an eye on like that. Actually, I think my wife took him for a walk. I'm gonna unplug that Alexa. It uses Wi-Fi and it also uses cellular. And you can track down your dog if he likes to roam around a little bit. I'm gonna unplug that real quick. Yeah, we don't have to listen to that again. So there we go. This is the I version of what I'm going to do. Again, my larger wiring, I'm not worrying about putting it in here. I custom fitted my wires to fit here. So I'm not overly concerned about them flopping around. It's mostly for that lower voltage and the stepper wires and things like that. So yeah, so before I get too far here, I don't want to take up a bunch of time, and I'll probably do this off camera, but I do want to show you real quick the problem we have here. And if I look, I can see copper. I can pull this right out. And what that was is me getting a little overzealous with the crimper, and I actually cut the copper on the inside of this connector. That's something you gotta watch out for. It's on the floor now, and let's see if I can get it up here. Yeah, if I look inside there, I can see the copper kind of chewed right off, and I'll have to fix that. But when you make connections like that, you don't want to give them a little tug, make sure they're nice and tight. So we'll fix that before we get too far into it. Like I said, I'll do it off camera though. There's no real sense in sitting here doing that while you guys are watching, assuming that you don't like that type of stuff anyways, right? All right, get rid of my trash. And let's go to this overhead camera real quick. So this is some more of the wire, and this is a complete mess. Believe me, I know. But there's no good way of wrestling this wire in the proper locations. So let's talk about these in a little bit here. So these ones with the black on them, you know, these are all from the kit. These ones that have black on them like this, these are for our AB mounts, for our AB motor mounts, okay? So that's where those are going to go. So those are all set up. I'm gonna put them over here. And the rest of these are pretty much all the same with the exception of the extruder. Where's the extruder? The extruder, the extruder, the extruder. Where'd he go? Where'd he go? Oh, right here. The extruder one's a little bit different too. That one's not a coiled wire. They're using a strip of wire, and it's called E-step E-motor on here. And we'll probably make that the first one we actually hook up, and that's actually going to go. That's actually going to go right to this last unit. And the reason I know that, before we get too far, is following this wiring diagram that's provided by LDO. Is this the right one? Let's see which one I'm on here. Wiring guide 2.4. Yep. So again, I'm not a huge fan of this. It'd be much nicer if the pictures were clickable to enlarge them. Not going to complain too much, but that would be something that would be very helpful, folks at LDO, in case you watch this video at some point. So let's see here, right here, E-motor. So E-motor stands for extruder motor, and that's going to wind up connecting to this port right here. It's on the top here, and that's actually going to connect to our last connection right here that has an actual driver on it. We have one here without a driver, and I believe on some of these, nope, not this one. On some of these boards, some of these drivers are paired together. It looks like these are separate. I haven't done my research on the Octopus specifically to see if it is, but it looks separate to me, but sometimes these are paired together. But this is going to go in the second last, or the last one actually has a stepper driver in it. So let's do that real quick. So this will only go in pretty much, actually no, same connector. This can go in either way. They do label it E-step, E-motor. So E-step going to go on this far side down here. Okay, and that's going to wind up looping through, and it's going to wind up coming out right over here. Trying to get your wires overly neat at this point in the build is kind of a fool's errand, but having them in place so you know where they're going to go in the long run is not. So do everything with a little bit grain of salt, because you're going to move stuff around as you do stuff. Okay, so that's our E-stepper wire right there. Okay, next thing I want to do, I'm going to jump a little bit, going to jump around and talk a little bit about these wires right here that I built. So I had to extend my wires a little bit based on, mostly because the wires that they provided were a little shorter than I liked. Let me see if I got a for instance right here. Yeah, so this is the Raspberry Pi wire. So my Raspberry Pi is up here. It's not connecting directly to the board because I'm using the separate 5 volts that we're getting off this supply over here. So the wire that they give you for your Raspberry Pi is awful short and not usable for the way I want to do it. Where's that little board that I chucked? So they give you, again, this little breakout board here that you can get 5 volts off of your Octopus board. But we're not using that breakout board, so we're not going to need that connector. We do have the ferrule crimps, so I've re-crimped those on there. So my cable is quite long. It's like this, and basically I have my ferrule crimps on one end, and I have my terminal. These, you know, what are these called? I forget what these are called. We'll call them forks on the far end. It's not a ring terminal. It's a we'll call it a fork terminal. That's connected to the 5 volt power supply that's on here. So well, let's do that. The terminals on this board are also marked red and silver. So we make sure we get our proper positive negative. Some things aren't going to matter in this build if they're properly polarized and you have your positive, negative. But with any connection that's showing red in a different color, you want to make sure you get those proper. Be careful of those little screws too. You could easily hurt them. I'm going to take this and just going to loop it around and tuck it in there. Again, I don't need to bring it around the other way. It requires even more wire for one, and for two, I just want to try to keep this a little neater. And then I'm going to use this path they give us, and I'm going to lift this AC wiring out of the way a little bit, and I'm going to kind of pull that back, and we're going to keep on dropping the things here during the video because why not, right? Pop that off, grab this, but before I do that, let's do something else. Let's check some voltages real quick. I'm not so worried about the 24 volts because chances are that we're not 10% off on those. But on this 5 volt power supply, 10% is a half a volt. You could possibly get away with more than that, but I get worried when I'm relying on somebody else to properly set voltage on these things. So real quick, we're going to go ahead and we're going to test the voltage. And this is going to be the first time we give power to anything on this. And again, I want to note to everybody watching this that you know, you take responsibility for your own actions. But I will warn you that there is live AC power here. Once again, you could easily get hurt doing this. So notice how I'm holding this. It's not plugged into the wall. Okay. Then I'm going to plug this into the wall. And thought that was a lit switch, but it might not be. So the first thing I want to do is I got my voltage on. I'm going to set this to AC voltage. Okay. And I'm going to check my AC voltage. Well, we might as well just check it right at the source here. So let's go here and here. I got nothing. Here and here. And I still got nothing for some reason. What's going on here? I should have something. AC voltage. There we go. 121.2 volts. Not too shabby. So I'm going to switch this over to DC voltage now. And see if I can stand that up so it's viewable. Of course, So I need to be able to see it too, you know. And we're going to check right here. We're going to check our positive and our negative. And we got 5.08 volts. So we're fine. We're good. While we're at it real quick, I'm just going to check my voltage on my 24 volts. And I'm at 24.17, so that's good as well. Back on. Now, if you're under voltage at all, I would suggest going up a little bit. Being slightly over 10% or less is not bad. There are drops and things like that, but I got lights blinking over here on the Octopus. But I just wanted to check some voltages before we get the Raspberry Pi hooked up, since they're so hard to come by, honestly. So I'm going to turn that off, and that power supply is going to drain out. There's a little green LED that's gone off. This is drained out now. If I hook up to it, got nothing. Good. So it's down to nothing. So those voltages are well within range as to what we can use. And I think probably 99.9% of the time you'll be fine. But of course that 1% or that 0.1% of the time is going to be that time that you don't check it. So I'm going to lift up these screws over here on this end. And I'm going to unplug power first. Power is unplugged. Everything should be discharged at this point. It's been a couple seconds. And I gotta get my polarity correct on this. So negative is going to be on this side. Hard to work on. Well, let's at this angle here. Okay, and then our positive is going to be the furthest one away from everything else. And it's stamped right on the 5-volt power supply, the plus and minus there. In case you want to confirm that for yourself. Loosen that one up a little bit more. Gives a little bit more wiggle room to work with. Oh, you know what? Let's go ahead and pop that out. Just because we can. Well, we still can. And there we go. Yeah, while we have that, we also tighten that up. And you can't really see what I'm doing, but I am screwing screws down. Nothing special happening here. And again, this is based on if you're using a 5-volt mean well or similar power supply. If you're using voltage directly off of your controller board, it's going to utilize that little PCB that I showed you a moment ago, well, a few moments ago now, I guess. How long is a moment? I have no idea. So the one good thing about having these trays is the fact that you can kind of run your wire back and forth. So if you have a little bit of excess, you can get rid of it. So I'll get rid of that power plug for now, so I don't see it, it doesn't worry me. Okay, that back right there. All right, so we get that. We got our powered Raspberry Pi, the 5 volts there. What's next? What's next? What's next? What is next is our SSR. So the SSR on this, actually there's a note. There's a note on this about using the FATUS, Rapido specifically, or any high current draw Hotend. So specifically it's saying here that it's reported that the Rapido Hotend by Fetus draws a large amount of current during initial heat up, which means initial heat up is drawing probably maximum. Well, it's actually dependent on what you put in to your, either your print profile or into your clipper. But usually on a hot end, you're able to use 100%, so you can heat that up pretty quick. And honestly, if you use a heated bed for most everything else, you probably don't need to use 100%, but it allows it to heat up pretty quickly if you do that. So what they're saying here basically is if you utilize a Fetus or something that draws a high amount of current on heat up because it's a high powered, I don't remember if it's 130 watts or what it is specifically, but they're suggesting that you make some changes. Now, this is again where it gets confusing again, is because not only are you going to make this physical change when you build the printer, but you're going to have to remember this documentation, because when you go to set up your clipper, when you go to set the pins and what each thing does, you're modifying a default profile. So it's going to be difficult to find a profile that's going to cover everything in this. So you're going to wind up picking and piecing things out. Not a big deal, because when you get in there, you'll start to realize that, there's only so many things it can be. 75–80% of it's going to be correct, and then you just have to work your way through the rest. You're gonna basically throw, and more for the thermistor more than anything else, but for this, if you see this hot end getting hot when you expect your for instance, your bed to get hot, you got to misconfigure there. You can do it physically with wiring, or you can do it in software. You have that option. So basically what they're saying here is to modify the SSR signal connector from spade terminal to ferrule so that you can utilize the HE0 on the board to run your SSR, because that basically is drawing no current, because all it is switching your AC voltage, and then basically use your bed out to power your Fetus hot end, which isn't a bad idea. No reason not to do it. So we're gonna do it. All right. So we're going to connect HE0 to our SSR. I've already loosened up those, so I'm just going to tap these in like this and then tighten the screws down. You're going to want to make sure you loosen these up all the way, because you can, when using ferrules, sometimes you can have a false sense of, literally a false sense of security, because your ferrules might be tight, but you're not actually clamped in. So you want to be careful about that. So that's nice and tight. And that literally is going to run straight across, like so. We might have a little service loop in there, who knows, in the end. And then we're looking at the input here on this. That's another thing that gets kind of confusing for some people. Input is the low voltage coming into control, the SSR, and it is a negative on this side, positive on this side. On this particular unit, there's a little LED light on it that will tell us when it's going to blink. Blinking is good. It's blinking based on the frequency that the DC from the controller board is pulsing to pulse that AC. Because again, I think we talked about in a previous video, we're talking about the heated bed a little bit, is usually you never run your heated bed at 100% even during your initial heat up, because it can cause warping or tacoing or whatever you want to call it. It can do bad things. So on mine, based on the direction and how it is on my printer, the bottom is negative and the top is a positive. Okay, there we go. So I will note one thing here. I am not grounding my SSR. I could, and there's nothing wrong with that, but my Wagos are all used up. And that's not really an excuse either, because I could ground it to the frame, but the SSR mount and the base of the SSR are made of metal. It is mounted to a DIN rail, which is screwed to the frame of the printer. So in essence, because this is using a metal mount that comes with it, and it's on a DIN rail and it's screwed to the printer, it may not be a perfect ground, but it is grounded. My printer frame is grounded, so it is grounded. On my bed will be grounded separately because it's using a kinematics mount. Almost forgot how to say that, which means it's semi-floating, and the magnetic connections there, everything is kind of rounded. It's not so great. But here we're actually clamped in, we're actually forked into something. It's probably as good as it's going to get anyhow. So that's why you don't see a ground on mine. It is suggested that you do ground these, so feel free to do that if you'd like. All right, so we've done that, we've done this, and we've done the other thing. Where are we at time here? 45, okay. Do a little bit more tonight. We have our end stop. Let's see, this is Y, and this is what? Chamber. There's a bunch of these right here that they gave me that I don't really need most of. I think we'll get our Z1 or Z0. It's always odd for me. Z0, 1, 2, and 3 kind of wired up here. In these connections, there's a wider end one, and the wider one is going to go on the actual stepper. Okay, and we can put multiples of these on at the same time. I don't know if they're much different length on them. They might all be the exact same length for all I know, but I'll check real quick just to let you know. Yeah, they're all about the same length. If they're any different, it is marginal, and I don't believe it matters. So important note on stepper motors is that there is no common coloring on stepper motor wiring. It is not a standard. So sometimes, I know you're looking at the back of my head. I'm probably just gonna move the printer when I do that one because it's hard to do at an angle. But sometimes you have to check your wires to see what you're looking at. On the inside of a stepper, I don't have a diagram up right now, but on the inside of a stepper, pretty much what you have is two separate coils. They are at 90 degrees, 90, nope, they are at 90? Yeah, 90 degrees from each other. And it's basically for precision. It allows the motor to have a lot of control. Allows it to step. So 4 stepper wire mount, or stepper wires to our steppers. These I'm going to fold underneath the stepper itself. I'm going to bring across like this, and then I'm going to bring this one down after I leave a little bit of the excess up here, because I don't want all of my excess wiring to all wind up in the center, because it's going to get filled up, I have a feeling. So I'm going to bring that out down here. I'm going to leave that there for now, and I'm going to grab these little markers that they gave us. I haven't used them yet, but we have Z, and they didn't, okay, yeah, they gave us numbers too, good. 1, 2, 3, Z, 0, what's that one? B, oh, B's for. All right, we'll figure it out. All right, so we're gonna need Z, and since this is on the back side, this is Z0 right here, the front left. So that's the one we just ran. So I'm gonna grab one of my Z's, my 0 here. So I'm gonna put a Z0 on this, just so we have it labeled. Once these wires all get in here, it's gonna be hard to tell. And I'm not plugging this right into the board yet. Like I said, it's gonna be easier once we have everything on there. You know what? These are actually neater than I thought. They actually clamp together. If I can get it back off. I've never used these before. It's the first for these. The my original Voron 2.4 was a form bought kit. It did not come with a lot of extras. I'd consider this an extra. So yeah, then we have our Z0, okay? And then we have our Z1, which is going to be right here. I'm gonna route this around. Remember, AC power is unplugged. If it doesn't need to be plugged in, don't plug it in. Much safer without it plugged in. I'm just gonna, again, try to soak up some of this wiring down here. Maybe even put a little pinch on this. I don't want to pinch it so much that I'm actually creasing the wires, but just enough to kind of hold it in place. Okay. And then run this underneath. And we'll leave it right there. We'll put the little label on it here. We need the 1, so we got the Z. Where's the 1? There's the 1. We got our Z1, oh, or Z1, sorry. Z1. For everybody else that speaks English, I believe. Z1, Z1. All right. So Z0, Z0, Z1, Z1. Perfect. Okay. So we got 0, 1, 2. Okay. And this one we're going to route across again. And take up our slack by routing it, utilizing that space that they've given us. And put a little pinch on that, just enough. And again, like I said, we're going to wind up needing these wires up again. I got to apologize to Woody real quick. My friend Woody, he actually has painted these covers because he wanted them to be black, and I don't care much about them. If I had more time, honestly, I would. Oh, I see AB. I got an A one there too. So one for the extruder, one for the A motor, one for the B motor. Yep. Okay. Let's see, Z2. If I had more time, I would. And I told Woody I was thinking about it. Maybe I'll do it on my upgrade. But I could hydro dip those, and I thought that'd be kind of neat to match my titanium backers I have on there. So, all right, Z2. And then last but not least, take this, fold it down around, pass it over here, give it a little pinchy pinch, and then bring it down, same as the others. And Z3 is what it be. So Z3 is this one. It's nice that they gave you these. You have to get the label maker out. Okay. So all of my steppers are right here. And what are we at for time? Oh, we're almost there. Let's take a look real quick at the manual here, see if they give us a detail as to where they want these plugged in. If we're actually going into 1, 2, 3, 4, 0 and all those things, or if we're doing this differently, because I'll tell you what, it's been interesting. So according to the Voron design, let's see here. Actually, they're doing it by location. We'll look at that in a second, but front left would be 0, back left 1, 2, 3. Okay, so 0, 1, 2, 3 after the AB motors, steppers, sorry, stepper motors. Let me go over to here and see if they give us some indication of how they want them run. Of course, you can't zoom into these pictures very well, so it's kind of hard to see. Let's see here, not used, motor C breakout PCB. We don't care about the breakout PCB. These are out here. Okay, so I see them saying, let's see here, they're actually skipping a stepper. Not quite sure why, but they're doing, I assume, well, it looks like they're doing B and then A, and then a skip and then 0, 1, 2, 3 with, let's see, AD 0. Okay. So LDO is inserting their steppers into different locations. So this is the type of stuff that really confuses me. I mean, I don't want to hark on anything, but or harp, I should say. But I don't know why you need to move your steppers into different locations from the original Voron instruction. There's no good reason for it, and they shouldn't do that. But we'll get back to it. So I have to choose now whether or not I'm going to do it the way that LDO is doing it, or the way, again, they are showing that it looks like they're B and then A, and then skipping a driver, and then doing their, their 4 Z wires, whereas on the Voron, they're doing their AB, and then they're skipping one after the first, which also is kind of odd. Unless those are tied together. Let's see, 0, 1, 2, wait a second, 2, 1, 2, 2. Okay, they are. All right. So remember earlier when I was saying that sometimes these things are tied together? They have a 0, 1, 2, 1, 2, 2, 3, 4. Okay. That's why LDO is doing that. Is this supposed to be an octopus? This looks like an octopus. Yeah, 2, 1, 2, 2. It's right there. So I have no idea why the Voron build that could cause you issues. So we're going to go with the way that's being done on the LDO manual for this, which is not the way I was going to do it a moment ago. So we're going to count up 3 on this. We're going to start at 3. And basically we're going to have our A and B. We're going to skip 1, then we're at 3, that we can keep all of these in line. So we're going to start with 0, which was our front left. So 1, 2, 3, 4. And then we're going to do 1, which is our left rear. Z1. Try to keep this a little bit neat. Okay, and then Z2. Right there. And last but not least, Z3. Z3 being the front right. Okay, so I'm just going to tuck these in real quick. Try to get these to stay kind of put. They're not actually staying locked together. I could put dab of super glue on them, but I don't think it's worth it. If I move them down towards the base of these things, I think the wires will hold them in place a little bit better. So we'll do that. Bada boom, bada bing. Bunch of plastic rings. All right, so we'll take this, pull this down, showing up, move this a little bit like that, and then tuck this in. And you are not going to make the wires look extremely nice in here. Getting them relatively straight is a good goal, but they're meant to hide the excess. So use them for what they're intended for. This is the one closet in your this is the equivalent of that one closet in your house that that things get lost in, you never see them again. Or if you have teens or tweens, is the equivalent of the underneath of a bed for one of those individuals. And then you get this one, drop this one down. While I'm kind of finishing up this wiring right here, I'm gonna give a quick shout out to SK3D, my first Patreon, and Brad's up there too. And I just recently had another join. I have to look real quick to recall. I think it was it Mark Davis? You use your name as your handle, so I hope you don't mind me saying that, Mark. And then also want to mention to everybody out there that doing a lot of work now, or a lot of conversations, a lot of good things coming from some conversations with DeWitt 3D, TheFirstLayer, Golden Jaguar. I think we got some good ideas for some awesome content. I think it might be some of the best content on YouTube when it comes to 3D printing, but I might be biased. There's also a Discord that Rich over at TheFirstLayer just put up recently. I'm gonna have a link to that. It's not a permalink, it is a temporary link, so it may not work after a while. But if you get a hold of me, I'll get you a link to it. If you're into 3D printing, you're a nice person, and you just want to help other people out or find some help for yourself, you're welcome. If you're a party pooper, or you're a pain in the rear end, or you totally don't care about what people think and just want to be your own person, it's a community, so you gotta deal with it that way. Anyways, that's it for tonight. It's about an hour, or today, whenever you're watching this video. I do want to thank you for watching. If you haven't hit subscribe, please do so. I mean, you did watch the whole video if you're at this point. Leave me comments, ask questions. It's coming together pretty good, and hopefully yours is as well. And I'll check you next time.